Please take a seat.
No. It's probably not full 30 minutes or 25 minutes.
Okay. Very well. So now the next session is starting. It's time to silence the phones. And next talk will be Game Theory to the Rescue when hard decisions are to be made. So ladies and gentlemen, please welcome our next speaker, Alexander Hendorf.
Oh, probably wait until the talk's finished, but thank you anyway. Okay, I'm going to talk about game theory, obviously, today. So let me introduce myself. So in my day job, I develop and I consult. So I'm moving vertically through things. And I review technical solutions, and we work on bringing high-tech startups together with bigger companies if they have something that helps both companies. So that's what I'm doing in the daytime. If you have a challenging high-tech startup, talk to me. Maybe we can help you. And also, I'm one of the organizers of the conference here, program chairing. I'm also active in the MongoDB community. I like to talk, and if you have any comments, questions, feel free to ping me on Twitter later. Game theory. We will only be able to scratch the surface of game theory today, so there won't be no coding. Last chance to leave now. And I hope I can give you an idea about game theory, because it's a little bit alive beyond if, else, if. It's a glance into a different life a little bit. I stumbled across using it just like by coincidence at the beginning of the year, while actually the call for proposals were running, yeah, people seem to like the idea, unfortunately. So, I mean, game theory is a very human concept. It's not tech. It has a background in economics and philosophy, and I think you can imagine yourself, like our world is getting much more hectic, complicated, so many options, decisions, and we are required to make decisions all the time. And sometimes this can be really difficult or stressful. And we very often worry, did we make the right choice? Did I pick the right Pokemon to win the next challenge? Yeah? So little knowledge of game theory can become really handy, not only coding in life, solving some problems. And yeah, it's about making the best decisions you can, but probably not only best decisions for yourself, also the best decisions for you and the people who surround you. We'll step into that later. So just think about, how do you make decisions? How do you make judgments? Do you really note down like the pros and cons and weight them up? Some people do, some people don't. They very much rely on their stomach, as we say in Germany. So think about, do your decisions affect others? And do you care about it? And that's supposed where game theory is going. You have to anticipate the decisions that others do while you're interacting with them, and how they impact you and how your decisions impact the others. And yeah, this is basically like the basic idea of game theory. And actually, I stumbled across it. For one client, we're getting messy accounting data in from some very popular online platform for videos, and we can check what's in there. Like sometimes they just match by some word stuff we don't really know, and we try to account to the people who gave the video material or audio licenses. And So we could do it manually, but it's like really a lot of data. We would be like many people and not effective because it's really a penny accounting business. And so we also use like systems like, for example, like Elasticsearch. And Elasticsearch, who knows Elasticsearch? Yeah, most of you. So you know you can also like get a probability back on the quality or the results you get. So how you get some indicator how Elasticsearch thinks, how accurate the result is. And so we have something to work with. We have also like customized systems. We can look directly in the database. We have done some funny search stuff. I don't want to go too deep in this, but just like I was really stuck like in the combination of all. Okay, I have all these expert systems I can ask, and probably one expert system will improve my input. And if I put it into the other expert system, I can even get better input. And so I was getting really confused, like, and so I thought, what about game theory? Because I can't really use if, else, if, then, to really solve it. And so I remembered game theory and gave it a try. And so let me introduce you a little more into game theory, and I hope it will help you to make decisions in your coding or whatever problems you're facing, or like basically maybe just in your life, or maybe even better in your life. So, game theory. Very often if you see a picture about game theory, you will see chess. And yes, but it's actually a very bad example, because is game theory about playing games? No. Again, you can leave if you thought this is a game talk. It's not about playing games, it's about interactions between humans, which we can also like pretend. We can basically imagine it's also like a game, like simplified version of interactions. We can regard this as a game. And we know games like chess or Go or tic-tac-toe, but they're deterministic. Every player knows at every stage of the game everything. You can see, if I'm white, I see the white player on the board, and if you're black, I see the black player on the board. So everything basically, it would be like playing poker with all cards on the table all the time. And basically it's just like you can calculate all possible results. Yeah? Of course we don't, because our brains are not capable, and even computers are not capable of calculating all the results imaginable for each and every move in time. So it's imagining like game theory having all the cards on the table. If the information is it's not having all the cards on the table, some information might be hidden. And is there a way to determine how you still can evaluate chances, build up a strategy? And basically this is what I was doing. As an 8-year-old, I believed I will win chess against the partner of my mother if I just chose the right color in the beginning. After I lost many, many games, I came to the conclusion that's not the case. It's very unlikely. But I think like the average chess player is also trying to find a strategy and anticipating what the next moves of your opponent might be, although you can basically calculate each and every possible result. You're anticipating what your player will do, you're anticipating his strategy, and this is getting us a little bit closer to game theory. And game theory was not just like invented overnight. Let's have a little glance into game theory history. It was like first mention goes back to the 1700s. Walgrave letters, the guys from Britain. There's a French guy who wrote a paper leading in the direction. And then in the beginning of the 20th century, things start to pick up with Ernst Zermolo. No, I can't read it here, sorry. Ernst Zermolo, über die Anwendung der Mengenlehre und die Theorie des Schachspiels. which actually can translate about how applying set theory in chess games. Then in the late 1920s, the thing starts to really pick up with a paper from a Hungarian scientist, John von Neumann. I think he moved to the US later. And he wrote another paper zur Theorie der Gesellschaftsspiele, which is about like theory in board games. And this paper got noticed a lot, and in 1944 he published a book co-authored with Oskar Morgenstern, Theory of Games and Economic Behavior. And so we see already the game theory thing is very close to economics, and usually we think economic and people caring about economics, oh, that's just a soft business, it's not like programming is much more better. So we don't probably look into theories there. And the challenge is can we build up a mathematical model? Can we basically analyze or calculate results of people's actions, the decisions the players might do? And basically, that's probably the most famous thing in the 1950s. It's like the prisoner's dilemma, and John Nash came up with the Nash equilibrium. Word. Yeah, it's very famous because like John Nash's life was a Beautiful Mind movie, so he's very popular. And by the way, this is a picture of John von Neumann, the Hungarian scientist. So, background, game theory is in economics, political science, and psychology. It's used as well in logic, computer science, biology, and poker. It's a mathematical approach to real-life simulations. There are situations that involve two or more decision makers. And each decision maker, you for example, has a number of different actions they might take. And the ultimate outcome does not just depend on your actions, it also depends on what the other people do. You are forced to think and come up with a strategy. And this is basically. So let's start with a really simple game. That's with something easy and practical. It's called zero-sum game. And the zero-sum game is the winner takes it all. And the others gain is the others lost. And I'm really happy so many people, and it's so crowded, because I would like to play two-finger Mora. So please partner with the one on your right. Everybody picks the right partner. Oh, well, I did. It doesn't work. Yeah, it doesn't work. Yeah, that's not like two. Yeah, sorry. I thought you can go from lunch and have a nap. I'm sorry. Now back to action. So, two-finger Mora is a very simple game. Pick a partner, and you basically you have two choices: show one finger or two finger. And you have to decide who is the even player and who's the odd player. And then, just like as rock and scissors, you play with your partner, you show your fingers at the same time, and if the result is even player wins, and the result is odd player wins. So you basically have 50-50 chance. So, and you have 5 minutes, and I will be back once you have the results. Okay, yes. Yeah, oh, you did a simulation. Okay. Oh, yeah. All right, guys. 5 minutes was a joke. Oh, yeah, really. You're enjoying this. Okay, we continue now. It's good to hear you all have fun with. I didn't imagine this simple game would make you so lucky. Okay, but basically, what would be like a mathematical representation of what we were just like doing. Yeah, we call this like the strategic form, and basically on one hand we have A wins if the count of fingers is even, and B wins if the count of fingers is odd. And we can just make the table. This is player A and player B, and if it's even, one gets a 1 and the other loses, so it's a -1. Yeah, that's like what we call the strategic form. And this is also like the basis one can calculate on with like these matrices. Zero-sum games, one winner, one loser. It's very competitive. And there's another nice way. It's called non-zero-sum games. It's more about synergy and everyone games. And for example, like doing the same game in a little bit different form. So let's do a non-zero same game, but please don't get as excited as... Yeah. I have only 15 minutes left, and I have to get you to Prisoner's Dilemma. That's my goal. Let's play the positive way of this thing. Let's do the same game, but a similar game. So if you show the same count of fingers, each of you gets 2 points, and if it differs, you only get 1 point. And this is basically more about cooperation. You want to give it a try? No, I think everybody can imagine. You have the idea, so you can like interactions, and this is like very simple interactions put into a matrix, and we can work with that. There are games with perfect information. As I mentioned, chess, Go, tic-tac-toe. So everybody knows about everything and all the options and outcomes for the other players. And there are games with incomplete information, basically life. Yeah, that's like the two. And as next, that's like the classic game theory thing, is the prisoner's dilemma. So, what is the prisoner's dilemma? The prisoner's dilemma, imagine there are like 2 criminals. They're already with the police. The police has caught them. And imagine having them in 2 rooms in the police district, in the police headquarters, and they're being interrogated. And the dilemma is, each of the 2 criminals does not know how the other criminal will decide. So, if you cooperate, I mean, if you ever have seen one of the US series, they say, if you cooperate, we can make a deal with the DA, and yeah, you will get free. Yeah. So the thing is, if you cooperate, you might get free, you don't get any sentence, but what if your colleague, your criminal colleague, your cooperator, conspirator, also is cooperating? Because then both are cooperating, and it's not that, all the criminals cooperating, they're just like saying, yes, we did it, we're so sorry, and everybody will get free. Of course, they will both get a sentence, a reduced sentence, yeah, on that. And the other outcome, of course, is just stay quiet. And probably the police won't be able to prove anything, or probably only like a minor crime, and then you might only end up with like a 1-year sentence. And this is the prisoner's dilemma. We have a nice couple, and they might have done some crime, I don't know, I don't judge. And we have them in 2 groups. And now let's get it into our strategic form. So, confess. Both confess, they get -5, which is 5-year sentence each. Keep quiet. Yeah. So if the other one confesses, you're really screwed. Yeah, you're really screwed. You go to jail for 20 years and you don't want that. And if you both keep quiet, we assume, yeah, okay, you will get some sentence, but not to the full crime. You probably might only end up in prison for 1 year. And how can you actually decide, because there's a dominant strategy, what we call in game theory, it's a dominant, so what's always the best outcome you should choose. And actually confessing is, because you either go to jail for 1 year or 5 years, but never for 20 years. So this is the best choice. And also confessing is only the only strong Nash equilibrium in the game. And the equilibrium is basically when there are no more gains for no one in being in the games. So basically nobody wants to take any action because he can no longer gain from it. And this is, of course, in this simple game, this is just like one round, but just like imagine there's more criminals involved, like a gang of 5, and you have to think about, oh, what do the other 4 people decide on? And it is a completely different game, because probably they're a couple, they're very close, and they never will give each other up. But if it's just like some random guys you met on the street, and you formed the gang to break in, you might tend to decide, oh, let's better confess because I don't trust those guys, and also I don't want to be apart. I can be apart from them, but you don't want to be apart from your girlfriend or boyfriend for a time. So this is where things can get complicated. And how can we calculate stuff like that? We can use algebra. There's many approaches. Bayesian Nash equilibriums, we can do just like Monte Carlo simulations to get some results. And and there's some material you can look into. There's a Python tool called Gambit. You can just play around with and think. There's a really nice blog post from a biologist, Martin Jones. It's evolving strategies for an iterated prisoner's dilemma tournament. I think it's very descriptive with outcomes and everything, so I had really a lot of fun reading it while doing research for this talk. And there's also from Stanford on Coursera a game theory course from Matthew Jackson, which I think is really good, very well taught stuff. And I hope I was able to give you a glance into game theory, a little bit different approach on thinking. And I hope you had a good time. And if there's time left, we can play some more Two-Finger Mora. Huh? Yeah. Okay. Yeah. Thank you.
Questions? Yes.
Hi.
Hi.
So first, thank you very much for the talk. Can I ask you that you go back to the slide where you have the matrix?
Like this?
Yeah. So here it's very clear
Can you
that...
speak up a little bit? I hardly can hear you.
Okay, yeah. So here I think it's very clear that the optimum for both, if the goal is that they both serve minimum sentence, is that they both keep quiet. But you said that the Nash equilibrium is basically that if they both would confess.
Yeah, basically that's the best strategy is to confess.
Why?
Because there's no better strategy not confessing. But the thing is, you can calculate like
I mean,
probabilities.
I don't understand, sorry to interrupt you, why you would prefer being in prison for 5 years instead of 1.
Sorry.
I don't understand why you would prefer being in prison for 5 years instead of 1. I mean, I know they have good food, but...
No, the thing is, you don't know what the other one does. That's the problem. You don't know what your partner decides on. That's the whole trick of game. Thank you for the question. That's the key. You don't know what the other party does. Yeah. And so you need to make a decision on basically what's the best move, but you don't know. Yeah. That's why this is the dominant strategy. It minimizes your loss. You will never go to prison for 20 years if you confess. So the minimum is like the maximum you can.
So basically, if you would keep quiet, you would basically risk a very higher penalty.
Yeah, basically, if you keep
Oh,
quiet,
okay, I get
it's
it,
a higher
thanks.
bet. I mean, if you know, it's you get.
So first of all, side note, I think it's interesting how people standing up and being very loud kind of is the tragedy of the commons, so another game theory concept. But my question really is, were you able to solve your data problems using game theory?
I was able to improve it. Because like the thing is, when do I end? Like putting like the information into the next system to improve it. So basically, I didn't mention it in the talk because it was a little bit deeper. You can also define a threshold. And if you know, like the gain will be minimum, and I think if I remember, it was like 5% or so. So if we say we think the information is 95% accurate, and after like also like a threshold of iterations, so it won't go on forever. I mean, if you just have one letter, we will never get a real result. That's the two things. Yeah, you can do the threshold easily. You say like, okay, percentage on probability or like iterations, and then just like take the result as is. It was very good for improving and interaction on multiple systems.
We have a few more questions. We don't have much time, so try to be short. Okay, this is done. We have one question more here.
Have you used the Python Axelrod tournament?
No, I haven't used it, but I've seen it online during your research. Have you used it?
It was developed by a friend of mine at Cardiff University.
Oh, okay, yeah,
yes.
great.
It's been very interesting in kind of raising interest in Python programmers in the dilemma. But I just wondered if you had a strategy in the tournament.
No, actually, I was quite surprised because I thought when I did research on when I was trying to solve the problem, I just thought, okay, Python game theory, I expected like at least 10 libraries, and the result there were hardly any. So I was quite surprised because usually there's a Python library for everything in life. Yes, it'd be great if we could pick up on the like helping and building stuff like that, and also like just like add game theory to our tool set of thinking when we're trying to solve problems. Because I know from like at least I feel being like programming a lot. You tend to think very deterministic. Yeah, this is the truth, this is the end. And game theory opens up your mind to be a little bit more flexible, finding a practical solution. Yeah, so that's, yeah.
Very well. We are out of time, so let's thank our speaker.
Yeah, thank you.
Run. ma sei italiano?
Sono italiano, sì, sì.
Ho parlato in inglese.
Sì, amici.
Amici.
Ok.
Ciao, stiamo cominciando. Ci siamo, eh? Quando vuoi. So we are ready for the next talk of this session. The title is Per Python ad Astra, and please welcome Juan Luis Cano.
Well, as the previous speaker said, there's a Python library for everything in life, even for rocket science. Well, let me introduce myself first. My name is Juan Luis Cano. I'm an almost aerospace engineer studying in Madrid, and right now working in finance as a Python developer for BBVA. I'm mostly a self-taught programmer because in university they used to taught us for a little bit of MATLAB, and well, we run all our algorithms in Excel, so it was not a great background to start with. And I'm a passionate individual about open source, open hardware, open science, and its relevance in the world that we live now. I'm also the chair of the Python Spain non-profit and organizing many events like the Python Spain conference, the Python Madrid meetup, and I remind you that the Python Spain call for papers is still open, in case you didn't, I didn't make it clear yesterday in my quick lightning talk. And, well, space, fascinating, isn't it? Well, I found something very amusing about space, and is that almost nobody knows how it works and what's going on up there, and yet it's like the only field adults are willing to accept their ignorance and ask all kind of questions. And I say adults here because children have this amazing superpower of asking almost everything, and this infinite curiosity that adults start losing with time. Well, so, wait a minute. Before explaining what is exactly this astrodynamics thing and giving any Wikipedia definitions, let's start with a little video. You might recognize here Clark Kent from the Superman Returns movie, and he's watching live through his alien eyes and this ridiculous haircut and wondering, what if I use my super strength to put this baseball in orbit? And so it goes, bye-bye, then the dog quickly runs to catch the ball and realizes the situation and turns his back to Clark like, seriously? And then, well, the bat hits some random guy in New Zealand or something. So what's happening here? Like, well, Superman is super, super strong, so if he's launching the baseball very, very quick, then he's going to reach a very long distance, and as the Earth is round, well, there are no flat earthers in this room, right? Because I'm going to disappoint you a lot. You might leave now. Okay, as the Earth is round, then the ground is starting to curve under your feet, so the ball is hitting some point to the other side of the world. Eventually, it's going to reach like New Zealand, the other side. And if you launch the baseball even quicker, then at some point, the ground is curving so fast that you never touch it. And this is what we call orbital velocity, or orbital motion, and free fall, because you don't actually need any propulsion or any means to like increase your velocity, and you are just falling all the time. This example is not mine. It was devised by Newton in his masterpiece of the 17th century, Principia Mathematica, and it's one of the earliest examples of a thought experiment, but obviously he didn't use Superman for the analogy. The title of the track of the piece is in Latin, and we will talk more about Latin at the end of the talk. Keep this in mind. Well, so with this in mind, what is astrodynamics exactly? Well, it's a branch of celestial mechanics that studies the motion of human-made objects through space. And there is a couple of essential differences between studying the motion of the planets and the motion of human-made objects, because the satellites, rockets, and stuff are so small that we have to take into account all the perturbations that might act to them. And also they have propulsion means, so they can act on their own trajectory and correct the velocity, and this complicates everything. Well, and this is where the introduction stops. I'm going to put a little bit of math, but I'm going to try to keep it very simple. I don't need everybody in the audience to understand everything, but I just want you to keep in mind the ideas that are behind these kind of problems. I'm going to talk about the basic problems that we solve in astrodynamics, and later on I'm going to say how do I solve them in Python. Well, the first one is the two-body problem, which is just one body orbiting around another one. Okay? In the limiting case, we are considering that these masses have no radius. Okay, so there are just like geometric points in space. And as we are usually considering like the motion of a spacecraft around a planet or a moon or something, then we can assume that the second body is very, very small and doesn't have any effect on the orbit of the first one. And that is the equation that controls everything. And the second one is the Kepler problem, which is like the initial value problem of the thing that I said before. I have some state and some moment in time, I have a position and a velocity, and after some time, I want to know where my satellite, my spacecraft, whatever, is going to be. This is called also propagation, and these are the equations that for the elliptical case that govern everything. And I want to put this here because that equation over there, the first one, if you remember your secondary school mathematics, you cannot solve that equation for E, for capital E. And that is for some people, they say that this equation is so difficult to solve that it motivated 200 years of mathematicians to develop many different and innovative techniques to solve it, and we made huge progress in mathematics thanks to the structure of this equation. And the last one is the Lambert problem, which is a little bit different, but it's still based on the same thing. I have one position, and I want to reach another position in a given time, so I want to know what is exactly the trajectory that I have to develop. In the earliest, like when we are designing a trajectory around the solar system, because I have some mission, as I will say after this, we can assume that all the planets are like points and only consider the gravity of the sun. So, to solve all these kind of problems, I created Polyastro, which is an astrodynamics library written in Python. It is released under a permissive license, and it has physical units handling. It solves all the problems that I said before. It included some basic 2D plotting, as we will say after this. And it would be impossible without the work of many, many people. I'm going to talk about a couple of the dependencies. The first one, in case you don't know it, is AstroPy, which is like a basic astronomy library written in Python. It's a joint effort of many, many developers around the world, and it's meant to have like the very building blocks of any astronomy project that you might have. For instance, it has physical units, which is like static typing for engineers, because if you mix meters with miles or something like that, then very bad things start to happen. It has also handling of dates and times. If you think that handling some time zones is a pain, then you'd better don't enter the astronomical times. It's a real mess. And it also changes the conversion between reference systems, so I can express one position with respect to the sun, with respect to the problem, etc. The second one is JPL-IFEM, which is a library by Brandon Rhodes, which is one of my favorite Python developers. And the thing is that the NASA and the Jet Propulsion Laboratory, they provide some planetary positions and velocity in very broad range that go between hundreds or thousands of years. And they provide them in a binary format, which is called SPK. And with this library, I can take that data and know exactly where a planet is going to be in the year 3000. Okay, so what happens with the very basic algorithms, because this involves like integrating differential equations and stuff like that. And when I started working on this, I said, okay, let's see what have other people done on this before me. And I found a lot of Fortran, MATLAB, Java algorithms that were okay because they worked and they had a very good performance. But the code was a bit poorly written. There were no tests whatsoever. They were very difficult to distribute because they were in a works on my computer state, released to the internet in a zip file. And wrapping those algorithms written in Fortran or in C++ or whatever from Python is possible, but it might be a challenge. So I ended up with a thing that only was known to work on my computer. And then some years after that, I discovered Numba, which is a project by Continuum Analytics that is also free. And it's meant to accelerate the code, the numerical Python code that uses a lot number crunching, numerical computations, NumPy arrays, and it supports a subset of the language and compiles to LLVM, which is the compiler toolset that is getting very famous now. And also it supports GPUs. So I tried to rewrite all the algorithms that were included in thousands of lines of Fortran only in Python and see, well, let's see how it goes. And these are the results of a paper that I presented to the European Space Agency some months ago. And if you can see here, the top line was the previous version compiled with the Intel Fortran compiler, which in theory is one of the best ones. There is the reference for all the performance measures. With GFortran, it was a bit slower, like I lost 30% of the performance. And then you can see, well, the bottom line is the Python code, which is like 2 orders of magnitude slower than Fortran, which is the expected result. And then you have here this Python plus Numba result that is visibly slower than Fortran, but is still more or less within the same order of magnitude. So I said, well, I'm going to throw to the trash bin thousands of lines of Fortran, a lot of pain, and in return, I'm going to lose 70% of performance that in any case I can optimize later or wait for the technology to develop. So this is more or less what I did with this Fortran code. Yeah, I was very happy to throw all this away. Because now the people that know Python, which are much more than the people that know Fortran, can easily contribute to my library. I can understand the code 10 months later after writing it. And the distribution is much easier because I don't need to force everybody in Windows to have a Fortran compiler. And in any case, who knows what's that in any way. So, to give a practical example of this, as this talk was presented in the hot topics call for papers, I wanted to bring something really, really hot, which is the arrival of the Juno mission to Jupiter the other day. If I can press this link. Thank you. Okay, wait a minute. The Juno spacecraft was a mission that NASA launched in 2011, okay, as you can see here, and it arrived to Jupiter 2 weeks ago. So it's been quite a long trip, and the trajectory was pretty involved, as you can see. There you have the orbit of the Earth in August 2011, and the first thing is launching this Juno spacecraft in a very wide orbit that even crosses the orbit of Mars. And you waste no fuel in all this arc here. And what it's going to do next is going to perform a maneuver over here in the point that is most far away from the Sun to correct the trajectory and try to encounter the Earth in a different point. So exactly at that point, without losing any fuel, it's using the gravity of the Earth to change the trajectory and go to the orbit of Jupiter. Well, the video goes, blah, blah, blah. And when we arrive to the end, I remind you that it was launched in 2011, and in July 2016, this arrived to Jupiter. And this is like cosmic billiards, because there was the planning of this trajectory involves a lot of man-hours, and you have to take into account the positions of all the planets, and for me it's so beautiful. And so, what we can do now is reproduce exactly this orbit with Polyastro. So if I go to this wonderful IPython notebook, let's do this a bit quickly. Okay, so here I'm importing a lot of modules from Polyastro, which include like definition of the planets of the solar system, the sun, some objects to provide an API. And here, for instance, what I'm doing is downloading these files from NASA that I told you before to compute all the positions of the planets. I already have them in my computer. And here are some data that I grabbed from the internet, like the date of launch, the velocity of the initial maneuver, the date of the flyby of the Earth, and the date of arrival. So, the first thing that I'm going to do is to recover the position and the velocity of the Earth in the date of the launch. And I can have here a couple of vectors. And as you can see, this is handling physical units using AstroPy. So if I use these high-level functions that I'm providing with Polyastro, there is no risk of mixing physical units. If I provide a vector in kilometers and another one in meters, then everything is going to be in order. And if I provide some incorrect unit, then it's going to warn me. So I create some state, which is going to hold some variables that we'll need later. And I do the same thing, computing the position and the velocity of the Earth the day of the flyby, okay? So then I'm going to use these maneuver objects to say, okay, now I'm on the Earth the day of the launch, and I'm going to do the first impulse to get into the first orbit. So if I apply the maneuver, and I see the period of the orbit, this means the time that it takes to one complete orbit to complete, then we see that it's above 2 years. So the period of the orbit of the Earth is obviously 1 year, so now I'm spending 2. If I plot this thing, then I have the position, the orbit of the Earth, and the first orbit of the spacecraft. If I go on doing this, propagating and computing some more velocities and data that I need, then I have not only the position of the Earth and the first orbit, but also the point where I'm correcting the orbit to encounter the Earth 1 year later. If I go on using these functions that you can check, I'm going to upload all the materials and plot this. As you can see, the API is pretty simple. Then I have this complete plot of all the segments of the orbit. You can see here the orbit of the Earth, the first segment, then the correction, this is the point of the flyby, and then this is the last arc until I go to Jupiter. I wanted to stop here because there are some limitations in the API of Polyastro, because for instance, I'm plotting all the segments that I don't travel through, for instance, like this one. So there is a little bit of noise in this plot, and also the 3-dimensional API is not existing yet. So I welcome any pull requests. So going back to my presentation. Well, the conclusion of this is that Python not only works as a language, but it can be fast enough using some tricks for some purposes, and we can optimize it later and improve the readability and everything. The ecosystem of libraries that we have for solving these kind of problems is amazing, and people is pouring a lot of work into this, and it powers a lot of different projects. There are several things missing in Polyastro, as I told you before, and the good thing is that open development, developing everything on GitHub, pouring good documentation, writing tutorials is key for encouraging collaboration and making this as easy to develop as possible. Before finishing my talk, I wanted to explain the title because it's a Latin catchphrase that used as a motto of the Royal Air Force, which was per ardua ad astra, through struggle to space. This open source thing, it's many times a struggle. Maybe you have felt it in the past, especially pushing it to businesses and companies. So I wanted to title the talk per Python ad astra to reflect that fact. And also I wanted to put again the picture of the International Space Station which is a collaboration between the United States, Russia, China, Europe, and many other countries, which for me means that even through political differences and historical differences, we can collaborate to build great things. So thank you very much. Keep dreaming, don't lose your curiosity, and thank you.
Thank you for a very, very nice talk. Do you have any question? Yes, we have.
This was awesome. Thank you. And now I want to say, I have a question. I read once that when we went to the moon, they were using, that if you look into the source code, they were using 6 decimal places for pi. Which was funny because usually we try to use like a lot, and no, you don't need that many, and you can put people there. So could we use this thing to send people to the moon?
No, and I'm going to explain why. Well, the first is that, contrary to popular belief, you don't need that many decimal places for pi, and if you use like 10, then you can approximate the circle of the universe to the size of the human hair or something like that. It's ridiculous. The thing is that with Polyastro, I'm taking into account only this problem, that is like only assuming that my body is very small, and also with the Lambert problem, that is calculating a trajectory from point A to point B. I'm only taking into account one body as a gravitational attraction. And when you are going from the Earth to the Moon, you cannot do that because the Moon is very big, it's very close to the Earth, and in all the trajectory you have to take into account both bodies. So for now, we cannot use it to go to the Moon, but we can go to Mars. The Moon is very boring, there's nothing there.
Very well, do we have other questions? Yes?
You recreated Juno's trajectory, which is great.
Sorry, can you repeat again?
You recreated Juno's trajectory.
About Juno's trajectory, yes. I don't think I have a picture here. Yes. Here, this one.
I was wondering how much time did it take to recreate it?
Sorry, I didn't understand.
How much time
how long
did
it
it take to recreate it?
To recreate it?
Yes, to do this.
I did it in real
notebook,
time,
right
now. Like, I just did it. I didn't have anything. Well, I calculated the notebook an hour before, but I restarted it, so I'm computing everything on the fly. Like, all the algorithms, like going from point A to point B, they are extremely fast now. And the complete trajectory, like, in real life, is taking like 5 years or something, or 6 years.
Other questions? Yes.
Hi, good talk. My question is, if from point A to point B is super fast, what would be a challenge on computing or on whatever for this library?
Yeah, the thing is that, well, I didn't say it, I think, but for many practical problems, you have to compute these solutions thousands of times. For instance, when you want to optimize an orbit and say, okay, I'm going to try this billiards thing. For instance, there was a contest some months ago, and there were solutions like, I don't know, go one flyby on the Earth, then Venus, then Mars, and then Jupiter, or there are many combinations, as, well, you can imagine that there are many combinations, and you have to compute these solutions thousands of times. So even if this is very fast to do it once, then if you start adding up and computing this a lot of times, then it's critical to have a good performance.
Other questions? I have a question myself, because I didn't exactly know what you were presenting, but I tested Polyastro because I'm doing calculation with orbital dynamics, but with satellites, low Earth satellites.
Ah, okay.
Are you going to add the J2 term someday?
No. Wow. No, and I tell you why. Because this is going to be optimized for interplanetary trajectories. So for low Earth orbits, you have to take many things into account, like the thing that the Earth is not a sphere, but it's like something like a pear, very strange, and also the pressure of the sun, because the sun pushes you when you are in orbit, and you can actually feel the light like displacing you. So I don't think I'm going to add those, but we have a parallel project which hopefully we will try to be more suitable for near-Earth objects.
So do you know any Python library that can be used for low Earth orbit?
Well, you have, for example, the library from Brandon Rhodes.
Yes.
Yes, you can, at least you can compute the SGP4 propagation model, which takes into account the orbital drag and stuff like that. So it's pretty accurate for most things, like for calculating when some piece of space debris is going to hit us in our heads.
Other questions? Okay, if this is not the case, please. Oh. Thank you again, our speaker. So actually, I evaluated your own source stuff.
You had tried it before,
yes.
Really?
Yes, actually, it stopped when I understood that it was for interplanetary.
But how much time ago? Because I started this like 3 years ago or something. I was studying in Milan actually when I started this.
I did it a couple of months ago, 2 or 3 months ago.
Nice.
In the end, I used Python Skyfield.
Ah, Skyfield,
And
yes.
with that, I would do the mapping of the...
You mean the ground track?
No, I really wanted the 3D stuff. I had to
Okay. Yeah, I have some three-dimensional plots, but the API is horrible, so I didn't want to show them.
No, but I desperately need the J2 term. I mean, I was trying to plot a sun-synchronous orbit. So, I mean, without the J2, it doesn't even exist.
Yeah, exactly. It's impossible. But we are working on it, but in a different project. Like I'm trying. This is like an experiment. Oh, sorry. Yeah, at first I'm taking this as an experiment to see like how do I design the objects and the API and stuff. And then when I have something very clear, then we're going to start another project for near Earth satellites.
I think what sometimes I'm going to give a talk just about daytime. Because I know what you mean.
Yeah, what do you think about deep synchronization? It's crazy.
müssen halt irgendwie Abrechnungen, bevor wir irgendwie Mist reinmachen. Und die Leute fragen, was ist da, lassen das weg oder geben es dann doch in Manual Review, wenn es ein größerer Betrag ist. Und wenn es halt. Ja, das ist doch. Das Ding dann ist aber wirklich
see if you have some water here. So you're the second speaker, right? Yes. Oh my god. The mics are on. That's good.
Yeah. Whoops.
Yes, there's this thing
There's
here.
this hazard here. Yeah.
Where are you from?
From Brazil.
Okay, cool. Are you flew in specifically for the presentation?
Sorry?
You flew in for the presentation?
Yes, but I live in Dublin. It's not a that long flight. Okay, that's what I didn't want to do.
All right. I think you have to mirror your screen. By the way, I think you
there
guys
was,
have a great service. I've done a couple of the Udemy courses, and I love them. So.
Oh, cool.
Yeah.
Thank you. Show me your option menu bar. Show.
So I think it's in the
Stupid
range,
machine. Yeah.
and then you mirror the displays.
I think I don't want that.
You don't want to mirror the
No.
displays?
But I want to move those off the. Okay. All right. So this is the main screen. Okay. But great, everything else is.
Yeah, probably you run the risk if you plug it in later that you have to do it again. So at least you know what.
I think that what I'll do is to close Windows. I really don't want to have the.
Yes, that's
And like Slack and.
showing you cards, 15 minutes, 10 minutes. What do you want me to do? Do you want me like to count down to the 45 mark to the end? Or do you want me like to take 5 minutes or 10 minutes off so that we can have questions?
I think 5 minutes is.
5 minutes, so I'll count like till 40, right? So I'll show you 25, I'll show you 15. So then we have 5 minutes to spare.
Okay.
For you, bro? Yes. Here's the last one, and then you can I'll show you the sign. So I'll be sitting around there. I'll be doing my last. You're the last speaker. I'm the second. Hi, you're the last. Okay, so we don't really care too much. 15 minutes to spare. Again, 16:45. 5 o'clock we have like option. Green free. We have the most shows.
I think I will have underrun actually. I think it's.
Yeah, that's what I mean. Most speakers do. So, do you have some water?
Yeah, one would be good as a reserve.
That's good.
So I had some issues with the beamer because it's so low resolution, but now it works fine, I think. 1 or 2 images are not perfect, but at least I can live with that.
Yes, it's always the thing, right? The resolution on the laptops.
Yeah.
Here.
Thanks.
Watch out, I put some water here so that you don't slip.
Okay.
Break your neck. That would be awesome. Did you enjoy the social last night?
Yeah, it was very nice.
Yeah, it was really loud though.
Yeah.
This morning I got up and I had a coffee and I went to order coffee and didn't have any voice.
I went out 2 times to talk people with outside, and then it was nice coming back
Yeah, I
again.
spent the time outside. Those are the best moments.
Okay. Oh, that's strange. No, the logo. It's not possible. Last time it looked different. I was here 10 minutes ago. Now it's fine.
Okay.
Yeah.
So your colleague told me you guys, you're 150 in your company.
Yes, exactly. Yeah. So we've grown a lot in the last years. And yeah.
Yeah, no, I assumed because I didn't know the company. So I kind of assumed that was like small startup. Pretty big already.
Yeah. So also looking forward, have interesting prospects. Yeah.
You're all located in Karlsruhe.
No, most of the people are in Karlsruhe, but we also have around 30 people in Hamburg.
Okay.
And in London, I think it's also around 15.
Okay.
And 2 in Dallas now.
Okay.
Okay.
Apparently another reminders to volunteers that they have to be in their rooms. Because I just got an email from somebody called Helen, no idea who she is, telling me I need to be in the pie chart room.
Okay.
Just yeah, because they have problems apparently, people not being there.
Okay.
Well, there's not enough talk managers to go around. So, are you also volunteering or are you also matching talks?
Yeah, I wanted, but I was only at the backpacking at the beginning.
Okay. Yeah, I was there, but I was still I was there too early at first. Some guys said, "Oh, let's go to the supermarket." When we came back, and it was already like a full line, and we were sent away. So now I'm doing my penance by doing more talks. So,
Okay, that's also fine.
Yeah, it's really kind of okay.
It was an interesting practice in self-organization at doing Milan.
Yeah, but we're fine. When we came back, it was like fully functioning, very industrial. Hi, welcome in this last session in the PyCharm room for today. Our first speaker is Christian Treibing, who's going to talk about getting in control of your workflows with Airflow.
So, hi, welcome to my talk. Yeah, getting control of your workflows with Airflow. I'm Christian Treibing, and I'm working as a software developer at Blue Yonder. So we have a booth also here. If you're interested, later on, just drop by and ask any questions. So, imagine the following scenario, which I know personally from my daily life. You are at a data-driven company. Each night, you get data from your customers, and this data wants to be processed. That's how you make money. Processing happens in separate steps. So, for example, you have to take care that this data is valid, you have to book that data, you apply some machine learning steps, you have to take decisions based on the results of the machine learning. And if errors happen, then you need to get an overview of what happened, why did it happen, when did it happen, especially since most of this stuff is running at night, and you need to see it next morning what possibly went wrong. And as you already might have guessed, you have a tight time schedule. So time does matter, and processing time. What options do you have to work in to realize such a scenario? The first thing that comes to mind of most developers is doing it with cron. And we also had many projects where we started with that. It's a great way to start. It works out of the box, but you only have time triggers. You cannot say this cron job depends on that cron job, please start afterwards. You just say at some time, start. So for example, at 22 o'clock, book your data. At midnight, do the predict run. And at 2 o'clock, do the decide run. Besides that, the error handling also is hard. You always have to search for the correct log files when something went wrong. So now, as I said, we have a tight time schedule, and you would like to get finished earlier. So as we see, each of these steps roughly runs around 1.5 hours, so why not compressing that? So we could do better. We could here start the predict at a half before midnight, and at 1 o'clock start to decide. Works most of the time, but sometimes your database is slow, sometimes you have other issues. And then one run takes longer. Here the book data run maybe takes 10 minutes longer, the data is not there, the predict run fails, the decision run fails, your completely run fails, which is very bad when you discover it the next morning, because your customer cannot get the data he wants. So that's an issue with cron. Because of that, when we used the cron mechanism, we always had buffers. And yeah, if the schedule was not too tight, that worked fine. But what about the next step? Our customer sends more data, the processing time gets longer, and we need to find better solutions. Why not writing our own tool? It's so simple. We just have to check that the first run stopped and that the next run will start. That cannot be that hard. And the start is very easy. In multiple projects, we did that, and it worked for the first steps, but afterwards, you see the limits soon. You have maybe concurrency, that you have multiple tasks running at once. You need to know why, what task failed. You might not only wanting to do timely triggers, but also trigger manual things afterwards. You might want a UI or an external endpoint. At that point, you have to take a decision. Either you can accept the limits, that's fine, or your own workflow implementation gets much more complex than you thought initially. So you are stuck. We were in that situation also. We wanted to harmonize all these workflow tools we had in our different projects, and we had to look at several open source implementations. There are many interesting things with many different properties. So, for example, we also had to look at Spotify Luigi, but this was more an HDFS-based tool, which was not in our technology stack, and also several other tools. In the end, we decided for Airflow, which is an open source project initiated by Airbnb, therefore the name Airflow. Why did we decide for that? Well, the tool itself is written in Python. We know that and we like it. And the one thing that was really cool is that the workflows are defined in Python code. So they are not sitting in some JSON files, not sitting in some database rows, but really each workflow is a Python code. You can enter it in your version control system, you get all versioning, and that's really a very good way of managing that. It has most of the features I said you will run within the limitations. So you can have a look at the present and the past runs. It has logging features. It's great that it's extensible, so you can write your own extensions in Python code and plug it in without having to modify the open source code, but it detects these plugins. I'll tell more on that later. It is under active development, so at the moment it's an Apache incubator project, and people are reacting on the pull requests, so there's lots of traffic in there, and you can see that it gets further. It has a nice UI, which I will show you. You can define your own REST interface, and it's relatively lightweight. You have 2 processors on a server, and you need a database to store all that information. How does a workflow look like? This is the Python code I talked about. Mainly, it is a dynamic acyclic, not a directed acyclic graph, each workflow. And you instantiate it, you give some parameters like when is the first run, what scheduling do you have? You can give that in cron syntax or in other, in time deltas also. And you can define your workflow steps as operators. So here I tell more about the operators later, but we have 3 steps. We are booking the data, we are predicting, and we take the decision. And the connection between these steps you do via the set upstream. So you say, before the predict happens, the book data needs to happen. And before the decide happens, the predict needs to happen. So this should be, the graphic doesn't work here. But okay, let's go to the next complex stuff. So maybe you want to have a fan in, fan out. We have more data. And the predict run takes longer. We want to parallelize that. And maybe we say we do some prediction for German customers and some prediction for the UK locations. So by that, I can say if you predict Germany, predict UK, both depend on the booking of the data, and the decision depends on both of them. So it's very nicely to describe, and it will give you that graph directly. By that, you can build arbitrary complex workflows. You also have the possibility for decisions and for switches, but at least for us, we did not need them up to now. So most of our workflows are quite linear, or just with a few branches in there. So how does the nice UI look like? I already promised you. You have here an overview where you see what workflows do you have, what is the schedule of them, and also what are the statuses most recently. So it's a little bit small to read, but you have here saying which tasks, how many tasks have run correctly, how many tasks are running currently. Also you can see what are erroneous and what are currently up for retry. You can run each view, you can have a look at each DAG run explicitly. So you see here the sequence. This is color coded also, that you can see which step was successful, which is currently running erroneous, and so forth. So this is a run that did not start. So this is just scheduled, but starting was not done up to now. The tree view shows you an overview of all the runs. So here you see each column is a run day. So you see for each day here, these 3 days went correctly, all green. And the last run currently had an issue here within the second step. It's yellow, this means it's up for retry. So you get a nice overview on how did it behave in the past and currently. Also which helps in that is a runtime view, for which you can see, for example, performance degradation, where we see here we have 3 runs, and these colors are all different tasks. So let's say this is the booking data step, the blue one, this is the prediction step, and this is the decision step, and you see one behaved the same, and the other 2 changed over time. So very useful for seeing which of the steps might have taken longer. You can see each run also as a Gantt chart to see when was each step happening. And you have a log view, which really is useful, where you can output things like, unfortunately it's a little bit small, Here it says the decision task has started a job in the backend system, and the job ID is 17, and the next iteration, it asks what is the status now, and then we see it is finished. By that you can see how each task was processed. Now, what are the building blocks of your workflows? These are operators, and there are already many operators delivered in Airflow. As an example, you can you can start things on the bash, you can start things with HTTP request, you can execute statements on databases, you can write directly Python code which is executed, or you can send mails. And this is just a few examples. There are more in Airflow delivered. They're not only these operators, but also sensors. Sensors are steps in your workflow that wait for things. So an HTTP sensor could, for example, always query an URL and ask whether it is finished or what is the status on that. And based on that, it will wait or it will proceed in the workflow. In the same way, an HDFS sensor could check for files on the file system, and an SQL sensor could check for values in a database. Many things already you can do with these operators, but there might be situations when you need more. For example, for us, we had an asynchronous processing in our backend systems. So we had here our Airflow system, we had our backend system, for example, the machine learning system for the predictions. We wanted to start a job, so we trigger an HTTP request there. We get back a job ID, and then we let it run for 5 minutes, half an hour or so, and we constantly ask whether it is finished or not, and when it is finished, we can start the next job. This would be possible to do already with standard methods of Airflow. So we could use the simple HTTP operator to start it, and the sensor, as I described, to wait until it is finished. This works, but it has the disadvantage that you don't see directly how long did it take. So you remember the last view with the runtimes. I would like to see how long did my decision take, and therefore I want that this step decide has a certain length, and the length is the length that it took on the backend system. So this is possible. We can do this with a new operator. I won't explain each line in detail. Also, you can find afterwards this as a complete Airflow example plugin on a GitHub repo, which you can see afterwards and can check for each line. So we have an HTTP connection defined. We have some endpoint decide that we can trigger that, and it delivers us a job ID, and we have a job status. We can ask when we have the job ID, what is the status of that. So within the execution, we run the post on the decide to get back the job ID. Then we wait for the job with the job ID, and once the status is finished, we are done. And then within the Airflow database, we know how long did this decision step take. Now, how do you get these operators into your system? As I said, we don't want to modify the code, the Airflow code directly, but we can do this in a Python package. We can say we have this plugin that has some own operators, that has some Flask blueprints, and lay that in our file system and in the Airflow configuration. We just can say your plugin is here and your workflow definitions are there, and on the start of Airflow it will detect them automatically. Also that plugin is defined in Python. As you can see here, we have the Airflow plugin manager, and you just say inherit from that Airflow plugin. We have our Europython plugin. This has 3 operators I need and also a blueprint. What is it about that blueprint? Why do you need that? We had the requirement, we wanted to have an endpoint to talk in a REST style with our Airflow system, so that we can also programmatically say, I want manually to start a trigger. I want to know, is a DAG run finished or not? This functionality was not there in Airflow, but you can write it as a Flask blueprint. You can define that endpoints, and it is detected automatically and added within the web server. Also this you will see in the example repo. How would such a REST endpoint look like? We have here the Airflow server running on port 8080. We have defined this endpoint trigger, and we say we give the name of the workflow, which is daily processing, and we get back the name of the workflow and the run ID, which we can use afterwards to ask for the status. So this works fine. Now what happens inside of Airflow, it works with two processes. At least two processes, I should say. We have a scheduling process that takes care when each job should run, and we have a web server that gives the UI and all the other blueprints. Also, you need a database. Several databases are supported. We are using at our company the Postgres and the SQLite. SQLite currently has a restriction that you cannot run parallel tasks on them. But we are using the SQLite more for the development testing stuff, so this is fine. And for production, you can use the Postgres, and there you don't have that limitation. You can also look how do you want your tasks to be executed. We are using most of the time just HTTP requests. We are saying we trigger a task in the backend system, we are waiting until it is finished. So the Airflow system itself, there's no high workload on that. So we are happy that this runs within the scheduler process directly, or when we want to have multiple tasks in parallel, we work with sub-processes. But it's also possible if you trigger the stuff via bash scripts or similar things that you want more power behind the executor nodes itself. And to do that, you can use Celery, which is a framework with multiple worker nodes, and you can use that. There is already a connection from Airflow to Celery. Yeah, how we use it, most of the things I already mentioned in the meantime. We use the automatic schedules, and we have manual triggers. We use one Airflow instance per system we manage, so we also had how do we that connection, do we have one central company Airflow instance or one Airflow instance per system, and for us it was easier to do it that way. Databases, we use Postgres and SQLite, the executors are lightweight, and also we are contributing to Airflow. This is really good, that works fine. These external triggers that you can trigger them manually, they were not there 1 year ago. And we needed them definitely before using Airflow, so we wrote a pull request that was also worked with, and now within these two pull requests, this is an Airflow. And we also have some necessary functionality for the plugin detection, so we also open pull requests there, and there's an active communication with the community. With all these good things about Airflow, there are at least a few challenges I want to make you aware of, because these were things we struggled a little bit, and also with the project teams using Airflow at our side. This has to do with how is scheduling handled and how is the start time interpreted. So scheduling, there are two dates that are important for that. It's the start date. This means when did the processing of this task, of this workflow start on the server. So that's quite easy. It's the time of the server. But there's also an execution date that is quite prominently shown on the UI, and that sometimes shows strange values. These values are consistent and they are explainable, but they are not always obvious. The reason is the history from Airflow. So this was used in ETL scenarios, so this extract, transform, load. And this means that for each, they wanted to process daily data, which was coming in the whole day long. So let's say on 19th of July, the whole day data came in, and then you wanted to process that data for the 19th of July. And when can you process that data? You can process it only after the 19th, which is the 20th. So let's say today. So today, this task of data processing runs, and what is the execution date? It's the 19th. So it's always one iteration back. This is because they said originally, well, this is more a description, this is the data from the 19th, therefore it's the execution date. That's fine. When you know that, it does not scare you that you think the system is doing wild things, but that's consistent. But yeah, you have to get used to that. We have some workflow starting in a weekly schedule, which means when I trigger that now, it gives me the start date of Monday the week before. Also that, it's consistent, but you need to get used to that. Then we have the start date. You might remember 10 minutes ago that we give a start date for each workflow. And if the workflow is scheduled automatically and you start the server, it will know that it has to fill up tasks. So when we say start date is today, 20th of July, no, we start the server at 20th of July, the scheduler, and as start date we have given the 17th of July, then it will detect that there are some runs missing, and it will fill these runs automatically. So it will first trigger the run for this with execution date 17th, then execution date 18th, and as a regular run, then the 19th will be processed at the correct point of time. You need to check whether this is applicable for you. So when you have these things, I need really to process this data, that's fine. When you have more the thing, I want to trigger something in the back end, and I need to trigger it just once, because this backend job will take care of all cleaning up that stuff, then this is a little bit strange and can lead to issues when you trigger it too much. But you can work around with that when you give the correct start time already. So you can determine that in code, you can determine that in a variable. There are several options, I won't discuss them in detail, but this is the thing you should have in mind when you do that. When you wonder why does this backfill happen, it's possible to handle that, but you need to know the concept behind that. If you have some further questions, maybe we can discuss afterwards. Okay, and that's it also from my presentation. I give you here, that's the incubator project for Airflow. It has a nice documentation, which is here. Also very useful is the common pitfalls page in the Airflow wiki. There also the stuff with the execution date is explained in more detail. And the plugin, which I have shown you parts of, you can find here at our Blue Yonder repo. You can download that. You have the steps in the README on how to use that in your Airflow instance. So that's it from my side. Any questions?
Yes, hello, thanks for the presentation. You showed us the GUI. Is it possible to manage task dependencies in this GUI, or is it just to display things that you wrote in the code?
The workflow definitions itself, you do that in code. So you can view that code from the GUI, but you have to change it in your code editor.
Okay, because well, in our firm we've got a homemade scheduler, and well, with I think 100,000 tasks inside. And is it scalable, Airflow? Do you use this amount of tasks in your system?
We don't have that high data volume in our system. So for us, it's more that we have per systems these nightly runs that have several tasks, but not thousands or millions of that. I've seen in the documentation page from Airbnb, these stacks seem to be much bigger, so it would be worth to ask them what is the limit for that. But we did not reach it up to now.
Hi. I would like to ask about the execution date and the run date.
Okay.
Like, is it possible to configure it? Because we have like similar example when you collect data for last month and you want to run it, for example, 15 days later, or in the opposite direction. You want to like collect data for next month and run it 50 days before that. Like, is it if you can configure it, like the delay, or maybe even if you can postpone it. If you see, okay, I will run tomorrow, but if I have no data tomorrow, I will retry the day after tomorrow.
Well, at first, the logic is not configurable. So this is in the scheduling code itself. Regarding the stuff running 2 weeks after or 2 weeks from now, I would say I have no quick answer to that. Maybe we could discuss it afterwards. I think you can do many things with the scheduling. So because the scheduling just tells you when does it run. You also have the possibility to schedule a run each day. And as a first task of the run, decide on whether you really want to run or not. So this might be the first iteration when you say you implement the more complex logic than in your first task, but maybe there's also other things.
Okay, thank you.
Okay, let's have one more question.
Did you evaluate other tools when you decided about Airflow, and why did you decide for Airflow?
Yeah, for example, we had to look at Luigi, but that was based on an HDFS stack, which we did not run. So therefore, this was too heavyweight just to have a workflow system to set up this. We also had to look at several OpenStack implementations, but their main focus was on doing heavy work lifting with execution processes and how these are distributed. And since we had very lightweight processes but needed more UI features and more possibilities to define own operators, this also just was not the main focus. When you see these two things great, but the main focus is a different thing, then yeah, it's good to have a look at other tools.
Because in theory also Jenkins does a lot of things like that with some plugins. So if you already have Jenkins, you have to convince your team to use something else. So what could be one thing that you can do that otherwise you cannot do?
I mean, Jenkins is great. We also use Jenkins for our integration testing, for scheduling our unit tests, but not for the daily productive runs.
Okay, let's give a big hand to Christian.
Yeah, thank you.
Wait. Oh, may I have a slightly off-topic question? Yes. So Airflow is used for like triggering tasks. Yes. What do you use for actually moving the data around, say from database to a database? That's not part of Airflow.
Yeah. We do this in Python jobs.
Okay.
So we have a machine learning system that extracts data from a database and then does all training or prediction and then writes it to the central database.
Okay, thank you.
Okay, so I'm gonna give you some glass. There you go. Oh.
This will end up killing someone.
It's because most Spanish are small, so they stand on the step. So I can make that joke because I'm small as well. Look, they're going for it. Okay, everybody's here. We have the final speaker for today. It's Ricardo Banfi, who's going to talk about lessons learned after 190 million lessons served.
Hi, good afternoon. Thank you for coming. I'm here to talk about some lessons. Before anything else, I have to say that I'm new to Udemy, and most of what I'll describe happened before I arrived. What I'll talk about is, therefore, the work of other people. And the lessons, however, I think they stand on their own. Well, this is where we are now. Udemy was founded in 2010. And in 6 years, it grew to 11 million students, 40,000 courses given by 20,000 instructors in 80 languages. The 190 million lessons served number I used for the title was gathered from a table that tracks students watching our videos. Lesson 1 is about preserving our culture as we grow. We are a learning company, and learning is in our DNA. For any healthy organization, preserving its culture is essential to its well-being. What I'll talk about is about the engineering team. Other teams have different things they do. Well, we are very serious about onboarding new employees. The idea is to get a new hire from a new hire to a productive engineer in the shortest possible time. We use extensive automation. We have standardized development environment that's reasonably flexible. And if you really want to, you are able to deploy our website on your first day. I did that in the first week. Even I can do it. We learn and teach ourselves using our own tools. There are Udemy courses about our applications from the user perspective, from the backend perspective, that are given by our own team. So you can hear about the application as it's described by the people who created it. We also communicate a lot. We have hundreds of people in 3 continents. And we span 11 time zones. We all hang out on Slack. We use HipChat until yesterday, literally. We just moved. We also use Scrum. We have the usual stand-ups, grooming sessions. We also have Hangouts. We conduct all hands meetings on Hangouts or other solutions if we have too many people. Every meeting room is capable of joining a Hangout. We have big screen, a camera, a good microphone, so we can join. We have meetings. We can have easily meetings that span more than one team in one place. Well, like I said before, we use automation a lot. We automate the quality checks. We can't commit ugly code. Seriously, we can't commit code with one extra line. We can't commit code with missing spaces. We can't push broken code. That means Git runs a basic set of tests before we are allowed to commit, before we're allowed to push. To commit, it's flakate, so still, anyway. And you can't merge if your code doesn't pass a very extensive set of tests. So you're absolutely sure that when you merge your code, you will not break anything. Also, we also use custom tools, custom Django admin scripts, custom Django admin commands to help prevent accidents. So, if you want to update a series of records, a series of objects in the data store, you will not be handed a MySQL prompt. In fact, it's very few people who have that kind of access. Instead, you'll do that through code that's reviewed by someone else, that's known to be, I won't say bug-free, but it probably is less bug-free than you typing SQL commands on the MySQL prompt. Even though we go to such great lengths to prevent that, some accidents happen. I myself deleted a shared database on my fourth week at the company. I was out of the Dublin office where I'm based. I was in San Francisco. And I deleted one of our shared databases. Not production environment, development environment. But thanks to me, the whole development team of the San Francisco office, which was very large actually, had a mandatory coffee break because no one could do anything. Yeah, there's some room for improvement. What we can do to that? Well, we have that shared database. We're working now to have an individual database for everyone with just enough data so that you can run your development with meaningful data. We also constantly make improvements to our development environment. We add, all the time we add code that makes it easier to develop. We add extra checks, we add some extra functionalities that were not there before. Personally, last month, I added a bit of code that made some tree objects represent themselves in a nicer way on the terminal on the IPDB prompt. It was a horrendously complicated logic, and by that I had someone lessened my cognitive workload so that with my somewhat limited brain, I could wrap it around a very complicated problem without having to worry about imagining what the objects looked like. I could just print them on the screen and have a look into them. The second thing, the second lesson is that as you grow, you have to, well, all the time you should be measuring everything anyway. When you grow, you will start measuring it in bulk. So, every application we have generates, collects metrics about itself. We collect those metrics in a huge, not Facebook huge, but still pretty impressive scale. For that we use stuff like Sentry, Datadog, and Chart.io. This is not, although this is considered something important to us, these applications are good enough so you don't have to develop them again. These guys are good. So, Datadog, Sentry for alerts, Google Analytics, and most of the front end is constantly monitored with that. Also, we have a huge user base. With that comes the possibility of doing extensive tests and experiments where you enable some feature and you can track on A/B tests how the user base behaves. Since you have a lot of people coming, you'll have good quality data on that. And we can actually know how something will impact us well before we enable it to the whole user base. This way surprises are minimized, which is good. I don't like surprises. That also allows us to have early warnings. If something starts to be, if you see the distribution, say, of execution time of a given function, and you have a peak at like 100 milliseconds, and you start developing a peak at 0 milliseconds, you know something is wrong. So you can watch those distributions on a tool like Datadog. And this data must be timely. We must receive it soon after it's collected. We must be able to see it immediately. This large user base is it's convenient because it generates a lot of data we can analyze, but it also amplifies any trend very quickly. And it's really not that good for you if you only know that what caused an outage of a week-long outage of a service. You don't want that. You want to know, if possible, before. Am I going too fast? No? Yeah, I suspect you'll like this one. It's about questioning and being a bit willing to abandon an approach. Let me say that. They, Netscape in this case, delayed a new version by 3 years. They did it by making the single worst strategic mistake that any software company can make. They decided to rewrite the code from scratch. Okay, this is Joe Spolsky. Who knows Joe Spolsky? Raise your hand. Well, for those who don't know him, he's a pretty clever guy. He created a lot of stuff we use daily, like Trello or Stack Overflow. Who uses Stack Overflow here? Come on. No, I don't believe you. No, no. Everyone should raise hands that. Okay. He said it in an article, this things you should never do, that everyone should read, even if you want to disagree with him later. Told you would like it. Yes, we moved from PHP. We had a large PHP application built on a custom-made framework designed internally by our founders. Who here has built their own framework? Who thought at that time it was a good idea? Who regrets that now? Okay, we're good. This is a problem because new hires have to be trained on a framework they have never seen. And it takes a long time. It ties an expensive resource. It ties an engineer that's already trained on that. And the engineer will be tied and not building useful things for the business, useful features, things users are demanding. That specific code base had very little tests. With the lack of tests, maintenance becomes walking on a minefield. And the fear of breaking stuff and not seeing it until it goes into production, or worse yet, until it corrupts user data, will drive you to adopt a very careful approach. You'll end up opting for safe changes instead of writing some more maintainable, more elegant, more performant code. You may even be tempted to replicate side effects of a previous implementation out of fear you'll break something you're not seeing. And obviously, this makes development slower and more expensive. So, what did they do? And I say they because I arrived right after the migration was finished. So I didn't even see that happening. That's such a shame. I'd love to see that. I'd love to be able to delete some PHP code. So, what did they do? No, they didn't jump for the first technology or the technology they loved the most. They actually created a project and evaluated. They evaluated the various options. They did a small proof of concept project with each of those, and with what they learned, they guided the decision. They looked into how easy it was to develop for that platform, what they knew, how well the platform encourages good practices, and how easy it would be to onboard new engineers on them. Yes, this is a serious project. It's not a lot of resources was put behind it. They set deadlines, they agreed on goals. They did that as if the company depended on it, because actually it did. Well, I know you probably have guessed which technology they chose, because I wouldn't be here talking about it. I would be on NodeConf or some other conference telling stuff instead of here. Well, what Udemy got, and what beautiful environment I have the luxury of working with. Well, we got a modern Django-based application. And modern, it runs on Python 3.5 and Django 1.8. We are considering the move to Django 1.9. It also allows us to onboard engineers much quicker, because Django is an opinionated framework and you don't have to teach every decision we made, every decision Udemy made. A lot of decisions are already baked in the platform. We have 88% of test coverage. That's not perfect. We probably will improve that. One of the things is that we can't commit code. We can't merge code if with the merge, the code coverage goes below a certain threshold. I have cursed this decision a couple of times myself. In the end, it's for good. With all that, we had also a lot of new features. We had a more consistent code base, which is what opinionated frameworks are for. And, well, there is some, of course, as anything that was migrated, there is some scar tissue where PHP and Django coexisted. Some table names are a bit odd, some field names are a bit interesting. And we have some special field types and some parts where we have to fight Django's opinions. And let me tell you, Django is very persistent in fighting back. Who had here to fight back? Oh, you laughed, come on. Someone raise a hand. Okay. And what did we learn from that? Well, the migration took a while. It was 2 years. 2 years with 30% of the engineering team dedicated to it. It was done incrementally, feature by feature. And there's a motivation thing on that. The team involved, the team responsible for the migration, track the progress by counting the lines they actually deleted. This is why I'm wearing this t-shirt. They call themselves the deletinators. With pride. Deserved one. I borrowed the t-shirt. I didn't delete any PHP line. So. All the time the website was up and running. And it was, as you would browse the pages, you would see a hybrid PHP Django application showing your page, showing the data you were used to. Also, since everything was changing, mindsets would have to change. So that's where the automated checks come from. So instead of ending up with an untested code base, they enforced some things that they consider mistakes. They learned from the PHP code base, and they worked against the impulse to allow the Django code base to be like that. There's also a final lesson here. This is about the importance of the mission. As I mentioned in the start, we are a learning company. We exist to help anyone learn anything. That's quite a goal. This also means that anyone can teach something to anyone else. We all have things we like to talk about. We all have passions. We all have stuff that we would like to teach other people if we could. Or there are stuff we'd like to know more, if only we could find a person who could teach us. What is the impact? About 1/3 of the Udemy students are starting or growing their own business using the knowledge they acquired through the platform for that. We also have lots of people who became full-time instructors who basically changed careers from being something to teaching. That's something they love to do. If you visit our stand, you'll see a couple sheets of stories of how Udemy changed the lives of those people. And I'll tell one of those stories, not one that's on the that sheet, those paper sheets. I'll tell the story as it was told to me by my colleague Erin, who actually knows this smiling, nice guy. He's Lynn Smith. He had a lifetime career as a copywriter. He wrote ads for companies like Vodafone, Lloyd's, BBC, IBM. And after this lifetime career, he decided it was time to retire. And to keep himself busy as he winded down his company, his career, he got involved with Udemy. And he decided to start, I can start teaching people to write proper copy. Well, it turns out he probably didn't retire, because as of now, he has taught more than 56,000 students. I myself was very impressed with this number because I was once a teacher, and my largest class was like 50, 60 students for a course that took 20 classes, 20 weekly classes. If I were to get close to what this guy did after he retired, it would take me 500 years to do that. This is a 10x guy, a 500x guy, probably. When I read the stories, when I read the messages our internal emails send forward that our students send, I see our mission is very, very important. In the end, everything we do at Udemy, everything we all do here at Europython is about the people, is about the community. It's about people, it's about teaching, it's about learning and sharing. This is what we do. Thank you. Oh, one more thing. In case you buy a course, if you use the import this for 0 code, you'll get a 40% discount.
Any questions? Okay, give a big, okay, there's...
Thank you. I know nothing about Django, but you said that you have to fight the framework back.
Django
Could
is
you, an example, like, I know nothing about Django. But
Django is an
like
opinionated framework. So it assumes you want to do stuff in a certain specific way. I know it's no longer the case, but a good example I can bring up is from, I think a long time ago, and I met that situation. I was doing an image bank for a portal, and we wanted to save the images, the originals, in a way that they would be deduplicated, which meant we would change the file name that was uploaded to a different one, and we would place it on a different folder than what Django wanted to do. It took me like 1 week to build the application and 3 weeks to build the logic to allow the application to save the files where we wanted them to. And it was really, really ugly code at that.
Anyone else?
Hi. You said that Django and old PHP code coexist at the same time, right? You probably didn't just flip the switch. So can you explain this a bit more? Like you probably couldn't use internal Django root system and other features. Like how did you manage to do this, that the both systems coexist?
Django and PHP share the same database with the same data. That's why we have some strange table names in some older parts of the system. The URL routing was done both on the web server and the Django application. So some of the URLs would direct to the PHP application, some would send you to the Django application. Is that what you wanted?
Okay, so after you launched fully Django, then you had to do some cleanup the code.
Yes,
because
the code
you
was
basically hard-coded some of the URLs and some stuff.
As the PHP code was being removed, the rules that sent to it, the code itself, it was deleted from the configuration.
Good. Any more questions?
Sorry, it's not planned, but I can clarify the routing. What we did is we had an Nginx front-end load balancer, and we had routes, custom routes, a giant routing table in there that would selectively route traffic to the Django app or let it route back to the PHP app. We just slowly deleted those routes and let more and more routes fall through to the Django app. That's basically how we flipped over without doing a big bang release. So if things went wrong, we could just simply add the route back in and went back to the PHP app again.
Okay, thank you for that. So I hope to see you all at the lighting talks. Let's thank Ricardo.
Thank you.